Good afternoon to all. Can you hear me? Voice audible? Shall we start the class?
Sir, audible, sir.
Right. A Fourier transform we have completed in the last class. The next topic is signals and system analysis using Laplace transform. Okay. So Fourier transform formula x of j omega equal to x of t e power minus j omega t dt integration minus infinite to infinite. Inverse Fourier transform that is for inverse Fourier transform of x of j omega formula, right? So in this formula, if you replace j omega by sigma plus j omega, I'm just adding one more extra term, that is sigma. Wherever j omega is there, if you replace j omega by sigma plus j omega, that is your Laplace transform. Okay. J omega replaced by sigma plus j omega. Here also j omega replaced by sigma plus j omega. Fourier transform formula, inverse Fourier transform formula. So let's take sigma plus j omega is a variable S domain. Okay. Now x of s equal to integration x of t e power minus s t dt. So s equal to sigma plus j omega. So if we do the differentiation in s domain, ds equal to sigma is a constant, 0 plus j d omega. So this d omega replaced by ds by j. So Laplace transform of a continuous time signal x of t. The formula is x of s equal to integration minus infinite to infinite x of t e power minus s t dt. Inverse Laplace transform of given x of s, that is x of t equal to 1 divided by 2 pi j integration x of s e power s t ds. So anyway, we are not going to use this formula to find the inverse Laplace transform. We will be using the partial fractional method only. So how we have done in the Fourier transform, similarly, we'll be applying the partial fractional method. And with the help of basic formulas of Laplace transform, we're going to calculate the inverse Fourier transform for the given x of s. Okay. So remember this formula. Laplace transform of a continuous time signal x of t. That is x of s equal to integration minus infinite to infinite x of t e power minus s t dt. Okay. S is the variable here. S equal to sigma plus j omega. So this formula derived from Fourier transform only by replacing j omega by sigma plus j omega. Right. Laplace transform pair x of t Laplace transform x of s. X of s inverse Laplace transform, you will get x of t. Right. Next, convergence of Laplace transform. Okay. So what do you mean by convergence of Laplace transform? Let's discuss. So the bilateral Laplace transform of a signal x of t exists if this particular equation x of s equal to integration minus infinite to infinite x of t e power minus s t dt is finite value. So this formula actually we have derived from Fourier transform, that is s is sigma plus j omega, right? If you replace s by sigma plus j omega, you will get this expression. And expand this particular equation, x of t e power minus omega t dot e power minus j omega t. Now if you compare this particular equation with Fourier transform, this is nothing but the Laplace transform of a signal x of t is nothing but Fourier transform of x of t e power minus alpha t. If you find Fourier transform of x of t e power minus alpha t, that is your Laplace transform. So we know the Fourier, what is the formula for Fourier transform? In general, x of t e power minus j omega t dt. So if you want to find the Laplace transform of x of t, that is similar to Fourier transform of x of t dot e power minus sigma t. Okay. The relation between Laplace transform and Fourier transform. We are multiplying some value with the given x of t. That is e power minus sigma t. So why we are doing like this? X of t directly we consider and we find the Fourier transform. In Laplace transform, x of t is multiplied with e power sigma t and then take the Fourier transform. So that is your result of your Laplace transform, actually. So x of s equal to x of t e power minus sigma t and then e power minus j omega t dt. So this equation indicates the Laplace transform is the Fourier transform of x of t e power minus alpha t. Therefore, necessary condition for existence of Laplace transform is minus infinite to infinite x of t e power minus sigma t. X of t e power minus sigma t should be less than infinite. Okay. So this is the necessary condition for existence of Laplace transform. Modulus x of t e power minus alpha t dt must be less than infinite. This is a condition for existence of Laplace transform. So one simple example I can give you. From that you can understand easily why we need Laplace transform. Suppose x of t equal to e power 2t dot u of t. Okay. Fourier transform does not exist for this signal. Why? What is the condition the Fourier transform exists? Integration of x of t dt should be less than infinite. So e power 2t ut. So integration 0 to infinite e power 2t ut, you will get infinite value. Okay. So if you plot this signal actually, t versus x of t, you'll get like this, signal like this. E power 2t, anything 0, 1. Then if you keep on increasing your t value, e power value will be increased. So this is your signal. Unbounded signal. Or in terms of system, unstable system. Okay. So Fourier transform does not exist. For x of t equal to e power 2t dot u of t. But in Laplace transform, what we are doing, how we are finding the Laplace transform? X of t multiplied with e power minus alpha t. Then if we find the Fourier transform, that is equivalent to your Laplace transform. So if you multiply this signal with e power minus alpha t, x of t e power minus sigma t. Okay. X of t multiplied with e power sigma. So this is nothing but e power 2t dot e power minus sigma t dot u of t. So e power 2 minus sigma t dot u of t. Now based on some condition, we can able to analyze the particular system. What is the condition? That with respect to sigma. So now this signal would becomes like this. For sigma greater than 2. For sigma greater than 2, we may draw the signal x of t e power minus alpha t. For this particular example, for sigma greater than 2, this is the signal. Sigma equal to 2, e power 0, you will get 1. Sigma greater than 2, you will get decreasing exponential. Okay. So we do some modification in the x of t and then find the Fourier transform that is similar to your Laplace transform. Here sigma is called as region of convergence. Right? So e power 2 minus sigma t dot u of t. Now this signal is absolutely integrable. For sigma greater than 2. Fourier transform, we cannot apply the Fourier transform, this signal directly. But in Laplace transform, it is possible to analyze this signal with some condition. So this condition here called as region of convergence. In this particular example, for sigma is greater than 2, we can solve this Laplace transform for the signal. Okay. So remember that the unstable system we cannot analyze using Fourier transform, but that's why we move on to Laplace transform. We do some modification in the signal, and based on some condition, we can able to analyze that particular system characteristics. If x of t is absolutely integrable, then the Fourier transform is equal to Laplace transform. Just replacing s by j omega. Okay. If x of t is absolutely integrable, then your Fourier transform result is equal to your Laplace transform result by changing s by j omega. If not, if not, then we cannot say like this x of j omega equal to x of s, because s equal to sigma plus j omega. The sigma will come into the picture now if x of t is not integrable. Okay. So these are all some basics about uh, relationship between Fourier transform and Laplace transform and why we go for Laplace transform. So whenever we are solving the problem in Laplace transform, we have to define the region of convergence. Region of convergence meaning the range of values of sigma for which x of s is exist. Your x of s is valid for this particular range only. That is the meaning of region of convergence. I'll write down the definition. The range of sigma for which a Laplace transform converge or exist available is known as region of convergence, in short form ROC. So in the previous example, Laplace transform exists for the signal e power 2t ut for sigma greater than 2. Here the sigma greater than 2, this condition called as region of convergence. Okay. So similarly, any given signal, while calculating the Laplace transform of the particular signal, we have to define the region of convergence. In Fourier transform, there is no such term, but in Laplace transform and Z transform, there is a concept called as region of convergence. We should specify the region of convergence for every problem. While finding the inverse Laplace transform also, in sometimes in the question paper they will specify the region of convergence. Based on the region of convergence, we have to find the inverse Laplace transform. Okay. So I'll teach you clearly, no issue. Next, so we can plot this region of convergence in S plane. In S plane. So S equal to sigma plus j omega. Sigma is real term. J omega is the imaginary term. So sigma in x-axis, or sometimes we call it as real part of S. Either you can mention sigma or real part of S. What is the real part of S? Sigma. J omega in imaginary axis, or it can be represented by the imaginary part of S. So this is the S plane. Origin, that is sigma value 0 plus imaginary value 0. So this is the origin of this particular plane. And right side, 0 to infinite, called as right hand plane. Right half plane, otherwise. Right half plane. Minus infinite to 0 plane called as left half plane. Okay. So this is the structure of S plane. Sigma in x-axis, j omega in y-axis. Origin, 0 to infinite, this particular area called as right half plane. Minus infinite to 0 area called as left half plane. And if we find Laplace transform of a signal x of t, that is represented by x of s. So you will get numerator divided by denominator. The s term available in numerator also and in the denominator also. So if you find the roots of your numerator, called as zeros. Okay. And the roots of your denominator section of x of s called as poles. Okay. So in S plane, we are using some specific symbol to plot these poles and zeros. This cross mark used for indicating poles. A small circle represents indicating zeros. So what is S plane? How to find zeros of x of s? How to find roots of x of s? Suppose if they are asking to plot the poles and zeros of x of s, meaning we have to plot the poles by cross mark, zeros by a small circle. We will start the problem. Any doubt up to this? Basic formulas of Laplace transform. Relation between Fourier transform and Laplace transform. And convergence of Laplace transform. Okay. We are adding one more term, sigma. or the Laplace transform is equivalent to Fourier transform of x of t e power minus sigma t. If x of t is absolutely integrable, then Laplace transform, Fourier transform both are same, just replacing s by j omega. If x of t is not absolutely integrable like this, then that statement is not true. Then the sigma will come into the picture. And explain what is zeros, what is poles, and how to mention zeros in the S-plane, and how to mention poles in the S-plane. So all these topics are fundamental of Laplace transform. Problems or formulas of Laplace transform. First one, find the Laplace transform of e power minus at dot u of t. Find the Laplace transform of e power minus at dot u of t, and mention the region of convergence. Okay. Please remember, in Laplace transform, all the problem we have to find Laplace transform as well as mention the region of convergence. So formula for Laplace transform: x of s equal to integration minus infinite to infinite x of t e power minus st dot dt. It's the formula. So e power minus at ut, the formula integration limit now changed from 0 to infinite, because u of t signal exists 0 to infinite interval only. So x of t e power minus at, u of t value 1, and e power minus st dot dt. Solve it, 0 to infinite. E power minus t take outside, you will get a plus s or s plus c. E power minus s plus at. So integration e power minus s plus at divided by minus s plus c. Substitute the limit 0 to infinite. Okay. So in this step, we can find the region of convergence. How? Based on this s plus a term. Okay. If this s plus a term is positive, s plus a term positive, that is greater than 0. Greater than 0 meaning this is positive value. Okay. So e power, it is equivalent to minus t. If substitute t value infinite, e power minus infinite. E power minus infinite is what? 0. Okay. E power minus infinite equal to 0. E power 0 equal to 1. E power infinite equal to infinite. Please remember this. If s plus a term is greater than 0, then you will get e power minus t. So e power minus t is 0. Suppose s plus a is less than t, less than 0, meaning s plus a term is less than 0, meaning this is negative value. So this negative value, here 1 minus, minus into minus plus, so e power plus t. So that time if you substitute t equal to infinite, you will get e power infinite. Result is infinite. Okay. So first case I am assuming s plus a is greater than 0. S plus a is greater than 0. So this term is positive. Plus minus, plus and minus, minus t only. So e power minus infinite 0. Minus of this minus plus, substitute t equal to 0. So e power 0 1, 1 divided by s plus. Okay. So what I derived for S plus A greater than 0, x of s equal to 1 divided by s plus A. The Laplace transform of e power minus at dot ut, the result is 1 divided by s plus A. The region of convergence condition we have to derive from this particular expression, s plus A greater than 0. If you are assuming s plus A less than 0, that is negative value, minus into minus plus. So e power t. If you substitute t tends to infinite, your entire result will be infinite. Okay. So for this particular problem, x of s exists. The value for x of s is 1 divided by s plus A. Based on some condition. What is the condition? S plus A greater than 0. The region of convergence, s plus A greater than 0, or s is greater than minus A. S is greater than minus A. Okay. What is S? S equal to sigma plus j omega. Sigma is x-axis variable. So usually we written as real part of S. Real part of S is greater than minus A. Or sigma is greater than minus A. This is the region of convergence for this particular problem. Okay. Normal integration only, but during the substitution, we have to assume this particular term, this s plus A term. If it is less than 0, what will happen? In this example, if it is less than 0, that is negative value, your answer is infinite. For s plus A term is greater than 0, then we will get 1 divided by s plus A. So Laplace transform of e power minus at ut, the result is 1 divided by s plus A. But this result is valid for the condition sigma is greater than minus A. Okay, sigma is greater than minus A. This is called as region of convergence. So if we plot this region of convergence in the S plane, how to plot region of convergence in S plane? Real part of S, that is sigma. Imaginary part of S, that is your j omega. What is the expression? 1 divided by S plus A. In the numerator, there is no S term. So zeros are not there. In the denominator, S plus A, only one term is there. So S plus A, only one pole, that is S equal to minus A. S plus A equal to 0. S plus A equal to 0. So S equal to minus A. So this is the pole. Only one pole available, that is at minus A. A is a letter, but minus symbol. So if this is origin, meaning minus the left half plane. So I just mark somewhere else, any point, minus. Okay. X of S equal to 1 divided by S plus A. No zeros. Zeros meaning in the numerator term, we have to equal to 0. Find the factors for S. There is no S term in this particular example. In the denominator, S plus A. So only one factor is available, that is S equal to minus A. What is the region of convergence we got from the problem? S plus A greater than 0. For this condition only, we got x of S. If this is less than 0, our x of S is infinite. Okay. From this particular expression, we derived sigma is greater than minus A. So greater than meaning this side. This is called as region of convergence. Region of convergence. This region of convergence greater than minus a. So you have to mark minus a. I told you how to mark the pole by using the cross symbol. So from this particular point to entire right side of this minus a, the x of s is valid. Your x of s is valid. 1 divided by s plus. Okay. So for any given problem in Laplace transform, we have to find the x of s result also. Simultaneously, check the condition for region of convergence. So do you understand this basic problem? Because we suddenly moved from Fourier transform to Laplace transform. And the region of convergence concept also comes into the picture. I'll repeat once again. E power minus at ut is the signal. Substitute in the formula and take the minus t outside, you will get a plus s. Do the integration. While substituting your limits, just check if this s plus a is negative value, then negative, this is minus minus into minus plus, t equal to infinite, e power infinite, infinite. If we are assuming s plus a term is a positive term, that is greater than 0. Okay. So if this term is positive, minus into plus, you will get minus 1. So minus t. So t replaced by infinite, e power minus infinite 0. So minus of this minus, t tends to 0, 1 divided by s plus c. So for this condition only, x of s is valid. That is called as region of convergence. Okay. What is s? Sigma plus j omega. Usually sigma only we are representing in x-axis. So we are not bothering about the j omega while representing the region of convergence. Okay. Because in the s plane, sigma is the component in the x-axis representation. So real part of s is s plus a greater than 0, or we can write s plus a goes on right side minus a. S is greater than minus a. A real part of S is greater than minus a. What is the real part of S? Real part of S is nothing but sigma. Sigma is greater than minus. So 1 divided by S plus a. See, the pole is only one pole available, that is S plus a equal to 0, S equal to minus a. How to indicate pole? Using this symbol. Minus a. This is origin. So this is the right half plane, positive value. Left side, this is negative value we have to indicate. 0, minus 1, minus 2. In this example, minus a. We don't know what is the value of a, but it is negative value only. So at some point, you just mark this. Real part of s greater than minus a. Greater than meaning greater than minus a. Okay. So if this is minus 1, greater than minus 1 meaning this portion is the greater than minus 1. Correct? So this way you have to mark your region of convergence. So for the fundamental formula, while solving the inverse Laplace transform, so you are going to use this formula directly. Remember this, e power minus at ut. If I find the Laplace transform, my answer is 1 divided by s plus a. My region of convergence, real part of S is greater than minus A. It's a basic formulas of Laplace transform. First formula. Remember this formula. Second problem, x of t equal to minus e power minus at u of minus t. Minus e power minus at u of minus t. Find the Laplace transform and mention the region of convergence. Formula for Laplace transform, integration minus infinite to infinite x of t e power minus st into dt. Minus infinite to infinite minus e power minus at u of minus t. U of minus t is valid from where to where? What is the sketch for u of minus t? Minus infinite to 0, the magnitude of the signal is 1, correct? U of t meaning 0 to infinite. U of t meaning 0 to infinite. U of minus t meaning minus infinite to 0. So the signal exists from minus infinite to 0. 1. U of minus t value 1. Then e power minus st dot dt. Okay. So in the previous problem, how we have find the region of convergence. Similarly, we find the region of convergence. So minus integration of minus infinite to 0, e power minus t outside, you will get s plus a into dt. So you can change your integration limit to 0 to infinite and then you can check, or directly you can check, no issue here. So e power minus s plus at divided by minus s plus a. Integration result. Now substitute minus infinite to 0. Okay. Now you have to check. T equal to 0. T equal to 0, no problem. Whether s plus a is 0 or s plus a less than in 0 or s plus a term greater than 0, no issue. Because t is 0, e power 0, anything power 0. So you will get the result. So this minus we can cancel. So 1 divided by s plus a. 1 divided by s plus a. Minus of, substitute t equal to minus infinite. What will you get? If substitute t equal to minus infinite, what will you get? Here one minus is there. S plus a t. T equal to minus infinite. So minus into minus plus e power infinite. E power infinite result is infinite. Actually you will get infinite. So infinite plus anything, the result will be infinite. So suppose if you are assuming s plus a is less than 0, s plus a is less than 0, meaning this is also negative value, correct? So minus into minus plus t, e power plus t. Now you are replacing t by minus infinite. You will get e power minus infinite. So e power minus infinite equal to 0, 0 by anything 0. So if you substitute the integration limit as it is, your result would be infinite. 1 divided by s plus a plus infinite, result is infinite. But what I am assuming, if s plus a is less than 0, that is, this particular term is negative value. This minus into minus plus. So what you will get? E power t, correct? E power t. Now if you substitute minus infinite, e power minus infinite. E power minus infinite 0. So 1 divided by s plus a plus 0. So in this example, x of s equal to 1 divided by s plus a for s plus a less than 0. For s plus a greater than 0, you will get infinite result. You will get infinite result. So first example, e power minus at u of t. The result is 1 divided by s plus a. Second example, minus e power minus at u of minus t. The result is 1 divided by s plus a. But what is the difference? Region of convergence is differ. The region of convergence is s plus a less than 0 or s is less than minus a or real part of s is less than minus. Real part of s is nothing but sigma. Sigma is less than minus. So how to sketch in the s plane? Sigma j omega. This is origin. So 1 divided by s plus a. There is no s term in the numerator, so no zeros are available. S plus a. If you substitute s plus a equal to 0, s equal to minus a. Only one pole. So mark minus a. This is minus a, so left side you have to mark it. Region of convergence, real part of s less than minus a. So less than minus a meaning you have to mark this side. In this section only, your x of s is valid. Right? From minus a to infinite, your x of s is not valid. Okay. The x of s is exist from minus infinite to minus a. So that is called as region of convergence. So do you understand the concept of finding the region of convergence? Any doubt? As it is, if you proceed, you will get infinite result. When you are assuming this s plus a is less than 0 for this particular problem, so then only you will get 1 divided by s plus a result. So from this relation, you can easily derive the condition for region of convergence. That is sigma is less than minus. So this is another important formula of Laplace transform. Minus e power minus at u of minus t. If you find the Laplace transform, the result is 1 divided by s plus a. But the region of convergence, real part of s is less than minus. This relationship is very important for inverse Laplace transform finding. Fourier transform, if x of j omega given using partial fractional method, we can easily find inverse Fourier transform. But in Laplace transform, based on region of convergence, we will get different result. See, x of s is 1 divided by s plus a. What is x of t? Minus e power minus at u of minus t. In the previous problem, x of s is 1 divided by s plus a. What is inverse Laplace transform? E power minus at u. So based on your region of convergence, your inverse Laplace transform result of the particular given x of s will be differ. Okay, it should be noted because we will be using the same formula for finding inverse Laplace transform in the later classes. So note if x of t is causal signal, then ROC is right sided. From these two problems, we conclude that if x of t is causal signal, e power minus at u of t, u of t is a causal signal. That is, it exists only for positive value of t. Then the ROC is right sided. If x of t is non-causal signal, u of minus t is a non-causal signal because it exists during the negative value of t. Then the region of convergence is left sided. Please understand. First problem, ROC is greater than minus a. Greater than minus a meaning we are indicating the region of convergence by using these stripes, parallel stripes. That is the right side. Second problem, minus e power minus at u of minus t. U of minus t exists in the negative value of t. Negative value of t. So this is a non-causal signal. If x of t is non-causal signal, after finding the Laplace transform, we come to the conclusion region of convergence is left-sided. So that's all about today class. We shall continue the Laplace transform in the next class.